Okay, we're on Algebra I, June 2024. We're doing questions 31 through 35. So 31, graph the following system of equations on the set of axes below. So we have our first equation is y equals x squared minus 3x minus 6. And this is a quadratic equation. Not that you need to know that for this question, but that's what a quadratic function looks like. And this is a linear function, so y equals x minus 1. So the quadratic function is going to be a parabola, so that U shape, and then the other one is a linear function, so it'll be a line. Starting with the quadratic, we want specific points, so we are going to y equals, and we're going to plug in our quadratic equation. Because we want the exact points, we're going to go to the table. And I'm going to pick a point I can actually graph. So I can graph negative 312. My graph does go that high, so we're going to start with negative 312. So from the middle, left 3, and up 12. My next point is negative 2, 4. So left 2, up 4, make your point. And we're just going to keep going. Okay, this does go lower than this. Okay, we can go to our graph, and if I'm looking for that specific point, we can go to second calc, so second trace for calc, and I want the minimum because it's the lowest point, so 3. Left bound, so I want my little spider to be to the left of it. It doesn't have to be exact. And then right bound, so I'm going to move it to the right. And then a guess, so we're going to say about right here. And my minimum is 1.4999 and negative 8.25. So we could just say roughly right here, okay, because we do want that U shape. And then go ahead and make your U shape. Again, remember it is a U, not a V. Arrows at the end because it's going to go on forever. Make sure that you label. And there's our first function, or our first equation for the system of equations. Now we're going to move on to this one. So you can just plug this in the calculator. X minus 1, go to the table and get your points and use those. That's fine. Or I know that that's the y-intercept, so I'm going to go ahead and start at negative 1 on the y. I have a slope of 1, which means I'm going to move up 1, over 1, and just keep doing that. Because this is a line, we do want to make sure that we're using our ruler to make this line. So grab your ruler. And make your line, and gotta move the ruler a little. Okay, fits the whole graph, arrows at the ends, and throw on a label to that one. State the coordinates of all solutions. For the solutions, we're looking at where the two intersect. So we have an intersection here at negative 1, negative 2. Right, left 1, down 2, negative 1, negative 2, and then we have another one here at 5, 1, 2, 3, 4. And that's it. 431. 32. The table below shows the amount of money a popular movie earned in millions of dollars during its first 6 weeks in theaters. So we have weeks and then dollars earned in millions. And this is a statistic question, so we're going to go ahead and hit stat and edit. In L1 is going to be all our x values, so put those in. And then in for y, so our y is going to be inputted into L2. Oh. Okay. Because I want the linear regression, I'm going to hit stat again, go over to calc, and I'm going to linear regression, which is 4. Make sure I have x list as L1, y list is L2, and then go ahead and calculate that. So now I can make my equation. I'm just going to copy all of this stuff down first. So y equals ax plus b with an a value of negative 37.5714 whatever, and a b value of 215.66666 forever and ever. All right. So with that, I still need to make the equation. So this information is great, but the question asks us to write the linear regression equation, and we're rounding to the nearest hundredth. So y equals hundredths place is the second number after the decimal. So for a, we're looking at the 7. Look at the 1. The 1 says keep it a 7. So negative 37.57 for our a, x. And then for b, we're looking at this 6. Look over to that 6. That 6 says we're going to bump that 6 up to a 7. So plus 215.67. Ha ha ha. Anyways. If your calculator is not already set, which mine isn't right now, to get the correlation coefficient, we're going to hit second in catalog, and I'm going to hit this E just because, I don't know, and because I want to go to diagnostic on, and I'm going to turn that on. And I'm going to go back up, and I'm going to hit enter on this again, because now when I hit it, it's going to give me that r squared and the r, which I really just want the r. So, state the correlation coefficient. Again, that's the r value on the calculator. So my r equals negative 0.9848 whatever. And round it to the nearest hundredth again. So that 8, I'm looking at the 4. The 4 says leave it an 8. So we have negative 0.98. That's for that part. And the last part, see what the correlation coefficient indicates about the linear fit of the data. So it's negative, and it's really close to -1. So a strong negative correlation. And there's 32. 33, use a quadratic formula to solve the equation 3x squared minus 10x plus 5 equals 0. Express the answer in simplest radical form. So I have to use the quadratic formula in order to get full points for this question. And I want simplest radical form, which means I'm not just plugging everything in and getting a decimal and then that's it. All right. The quadratic formula is on your reference table. X equals negative b plus or minus the square root of b squared minus 4ac, and that whole thing over 2a. So there's my quadratic formula. On your reference sheet as well has the basic form for a quadratic function, and I'm not exactly sure if it's y equals or what, but y equals ax squared plus bx plus c. Okay, that can help you figure out what a, b, and c are supposed to be. to substitute in the formula. So for this equation, A, it's in front of x squared. In this case, it's 3. B is in front of x. In this case, it's a -10. And C is the constant, so the number by itself, which is 5. And we're just going to plug those in to start. So -10 plus or minus the square root of -10 squared minus 4 times 3 times 5. And that whole thing divided by 2 times 3. -10. Sorry. Oh, okay. -10 changes to a +10 plus or minus the square root, and I'm plugging in all of that without the square root into the calculator. So, -10 squared minus 4 times 3 times 5, and I get 40. So that's going to go into my square root divided by 2 times 3, which is 6. I want simplest radical form, so I do have to simplify the square root of 40. So the square root of 40, we're going to break it up into 2 square roots, and you want to find the biggest perfect square that divides into 40. If you're not sure what numbers divide into 40 or what numbers multiply to 40, you can go to y equals, you're going to put 40 divided by x, and go to the table. And this will give you a list of the numbers that multiply to 40. So from the calculator for 40, we have 1 times 40, we have 2 times 20, 4 times 10, and 5 times 8. Again, I'm looking for a perfect square, so those numbers are 1, 4, 9, 16, etc. So the biggest one on this list is 4, so that's what I'm going to use. 4 and 10. The square root of 4 is 2, and the square root of 10. So I'm going to replace that square root of 40 with 2 square root of 10. 10 plus or minus 2 square root of 10 over 6. And I'm going to simplify it even further than that. I'm only looking at these numbers in the front, not that number inside the radical. I can't simplify that. I can divide all of these by 2. So now it's going to be 5 plus or minus. If you want to put the 1, you can, but it's not necessary. So I can just put square root of 10 over 3. And that's it. If you wanted to, you could break this up into 5 over 3 plus or minus square root of 10 over 3, but that's not necessary. All right, 34. Graph the system of inequalities on the set of axes below. So 3y plus 2x is less than or equal to 15, and y minus x is greater than 1. We cannot graph either of these the way that they're written right now, so I do need to get y by itself, starting with this top one. So 3y plus 2x is less than or equal to 15. My goal is to get this y by itself. So first I'm going to move this 2x minus the 2x on both sides. 3y is less than or equal to. Do not change the inequality to an equal sign. That's not how that works. I usually put the x term first. You could write it the other way, it doesn't matter. And divide every single thing by 3. Y is less than or equal to -2 over 3x plus 5. So like I said in the other one, you can just plug this in the calculator. So into y equals -2 over 3x plus 5. Go to the table and get your points from there. That's fine. Or I know that the y-intercept is 5, so I'm going to go ahead and start at 5. 1, 2, 3, 4, 5. My slope is -2 over 3, so I'm going to go down 2 over 3. Down 2 over 3. Because there is this equal to, that means I'm going to draw a solid line. So just grab your ruler and make a straight line through those points, arrows on both ends. Inequalities also require shading, so I have y is less than or equal to, so I'm going to shade below my line. So all of this area right here, and you can just make lines coming out from your line. It doesn't have to be shaded any crazy way. And slap a label on there. Moving on to the second inequality. Again, I cannot graph this the way that's written. My y value is not by itself, so let's do that. This one's pretty simple. To get y by itself, I just have to move that x to the other side. In order to do that, I'm going to do the opposite, which is to add x on both sides. Y is greater than x plus 1. Again, you could just put that into your y equals, go to your table and get your points. That's fine. Or you can start at the y-intercept, which is 1. And the slope is also 1. So you're going up 1 over 1 to get to the next point. Because it's not equal to, this time I'm on a dashed or a dotted line. So I just connect parts of my dots. And you can use a ruler for this also. Okay, it is greater than, which means we're going to shade above the line. And then I'm just going to make my lines go the opposite of what they were before. And my double shaded area, so where the shaded areas overlap, is my solution set. So I'm going to put a big S there. Okay, make sure that you read. Sometimes I feel like they've used different letters besides S. So, but it doesn't tell us anything specifically. So there's our graph. We do have to label this. I almost forgot. And the second part of the question, state the coordinates of a point in the solution to the system. Justify your answer. So you're picking any point that's in this double shaded area. We could go with -2, 2. So we'll pick that point right there. -2. Oh, that's not 3. -2, 2. My bad. Justify, we're just gonna substitute it in. So 3 times 2 plus 2 times -2 is less than or equal to 15. That's 6 minus 4, which is 2 is less than 15. It works for that one. And we do have to check the other one. So 2 minus -2 is greater than 1. That's the same thing as 2 plus 2. So 4 is greater than 1. That one also checks out. All right, last question. Courtney went to a coffee shop to purchase lattes and donuts for her friends. One day she spent a total of $15.50 on 4 lattes and 2 donuts. The next day she spent a total of $18.10 on 3 lattes and 5 donuts. All prices included tax. If X represents the cost of 1 latte and Y represents the cost of 1 donut, write a system of equations that can be used to model this situation. Ooh. Okay, so to start, I want to underline some stuff that's important. So the first day she spent a total of $15.50, and that was on 4 lattes and 2 donuts. And the next day, she spent a total of $18.10 on 3 lattes and 5 donuts. I'm using X for the cost of 1 latte and Y for the cost of 1 donut. So I do not need to write a let statement for this one because they already give me the variables. And I'm going to write a system of equations, which means I need at least 2. Generally, it is just 2, but system could be more than 2. So my first equation is going to be for the first day. She bought 4 lattes, so 4 times X, which is the cost of 1 latte, so 4 times the cost of 1 latte, plus 2 times Y, 2 times the cost of 1 donut, and that's going to equal the total amount that she spent on the first day. And then I'm going to do the same thing for the second day. She bought 3 lattes, so 3x plus 5y equals the total that she spent. All right, Courtney thinks that 1 latte costs $2.75 and 1 donut costs $2.25. Is Courtney correct? Justify your answer. In order to see if she's correct, we're going to substitute into our system. So starting with the first one, 4 times, she thinks a latte is $2.75 plus 2 times her $2.25, apologize. And we're saying that that equals $15.50. 4 times 2.75 plus 2 times 2.25. That does equal our $15.50. So $15.50 equals $15.50. So it does work for the first day. We do have to check the second one because it's a system. So 3 times our $2.75 plus 5 times $2.25, and we're going to see if that's $18.80 or $18.10. So 3 times 2.75 plus 5 times 2.25, and that's $19.50, which is not $18.10. So no, Courtney is incorrect, or not correct, or whatever you want to say. All right, moving on. Now we're going to algebraically determine the cost of 1 latte. So there are 3 options when we're solving a system of equations. So one is graphing. We do not have a graph, so graphing is not happening. We have substitution, which is possible, but not my first choice for this one, the way that it's stacked up. And then the last one is elimination, which is the one that we're going to use. So in elimination, I want to pick, do I want to get rid of the x's or the y's? In this case, I think I'm going to get rid of the y's. In order to do that, I want to make these 2 numbers equal but opposite. So the same number but different sign. So when I add straight down, they will cancel each other out. In order to make 2 and 5 the same, I can make them both 10 by multiplying the first one by 5 and the bottom one by 2. So I'm going to stack them up again. I'm going to multiply this top one by 5 and the bottom one by -2 because I want to make it opposite sign. And we want to make sure that we're multiplying every single thing. So we get 20x plus 10y equals, let me just quick, 77.50. And then I'm going to go ahead and do the next one. -6x minus 10y equals -36.20. Now when I add straight down, these are going to cancel. 14x equals 41.3, and now I can solve for x. And I get $2.95, so $2.95 for x, which is the cost of 1 latte. So I have the cost of 1 latte. Now I need to find the cost of a donut. I'm going to take one of my original equations and I'm going to substitute that in for x. We'll just go with the first one. So 4 times $2.95 plus 2y equals $15.50. 4 times 2.95 is $11.80 plus 2y equals 1550. Now I'm going to solve for y, so minus that 1180 on both sides. 1550 minus 1180, 370. Divide by 2 on both sides, and we get y is equal to $1.85. So 1 latte, $2.95. 1 donut, $1.85.